Everybody, welcome to TheinSites YouTube channel. Today I'm going to start a new playlist. It will be the DS Important Topics playlist. In this playlist, I'm going to talk about some simple yet tricky concepts of data science, which I have faced personally during my learning period. And currently, I am working as a data science analyst in Tiger Analytics. So today our topic will be accuracy metric in imbalanced dataset. So let's begin the video. So today our agenda is to discuss about classification model, then balanced and imbalanced dataset. Then we will discuss about confusion metrics and what is accuracy, when do we actually use accuracy metric, why accuracy metric is not an ideal one in case of imbalanced dataset, and what are the metrics we can use in case of imbalanced datasets. So let's discuss about classification model. As we all know that classification is a supervised machine learning model. Supervised means that the target variable will be present in the primary dataset. And here, as it is a classification dataset, so the target variable will contain different classes rather than containing continuous values. Now, classification models can be binary, multi-class, or multi-level classification models. Some examples are spam detection, rain prediction, or match winner prediction. So what is imbalanced and balanced dataset? Now, the balanced and imbalanced data is completely decided upon the distribution of classes in target variable. If we take an example of a binary classification dataset, if the target variable contains two classes and the distribution between those classes are 50-50, 60-40, or even 70-30, we can consider this dataset to be a balanced one. But if the distribution of classes in the target variable is 80-20 or 90-10 or even 95-5 ratio, then obviously this is going to be considered as an imbalanced dataset. As an example, if we take a match winner prediction dataset where the target variable contains 650 wins and 350 defeats, it is going to be considered as a balanced one. In the same dataset, if there is 820 wins and 180 defeats, we are going to consider this dataset as an imbalanced one. Now, what is confusion matrix? Confusion matrix is a well-known classification model evaluation matrix. It contains 4 possible values. There are 2 parts, the actual values and the predicted values. As you can see from the figure, the actual ones are in horizontal and the predicted ones are in vertical. Yes is considered as 1, no is considered as 0 in both the cases. Now there will be 4 elements in a confusion metric. These are true positive, false negative, and true negative. True positive are the values which are actually positive and predicted as positive. False positive are actually negative values, but our model has predicted it to be positive. False negative are the values which are actually positive, but has been predicted to be negative. And true negative is actually negative, and also our model has predicted it as negative. Now, in confusion metrics, the false positive and false negative, these are respectively considered as type 1 error and type 2 error. Now, always in any classification model, our motive will always be to decrease or to reduce the value of type 1 error and type 2 error. Now, going further, what is an accuracy metric? Now, accuracy is also a widely used metric to evaluate a classification model. Now, accuracy is actually the ratio of correctly predicted results and the total predicted results. What does it mean? The correctly predicted results are nothing but true positives and true negatives, as I have told, that true positives are the results which are actually positive, and our model has also predicted it to be positive. And true negatives are the values which are actually negative, and also our model has predicted those to be negatives. So these are the correctly predicted values, and the total predicted results are obviously the summation of true positive, true negative, false positive, and false negative. So the accuracy is equals to true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Now, when do we actually use accuracy metric? Generally, accuracy metric is used in case of balanced datasets. That means where the classes are equally or nearly equally distributed in case of the target variable. That is, the distribution will be nearly 50-50 or 60-40 or even 70-30. But above that, that is 80-20 or 90-10. In these cases, the data set will be considered as an imbalanced one. Now, accuracy metric calculates the total percentage of correctly predicted values out of the total predicted values, as we have already discussed. Now, accuracy metrics doesn't perform well in case of imbalanced data set. Why? We will discuss further. So here we are. Why accuracy metric is not ideal for imbalanced data set? Now, imbalanced data set means, as I have already told, that the distribution of different classes in the target variable will not be equal or nearly equal. In these cases, the distribution between the classes are nearly 80-20 or 90-10 in case of binary classification. In this case, the classification model is trained on this kind of imbalanced datasets. And what will happen? Our model will be biased towards a particular class. As we are training the model with an imbalanced dataset, our model will be biased towards the abundant class only. It will not have the quality to predict any result to be the other class. Now, if we take an example, like suppose you have one binary classification dataset where the target variable contains two classes, yes and no. And we have 92 yes values and 8% no values. That is 92% yes values and only 8% no values. Now, in this case, if we train our model, our classification model with this imbalanced dataset, our model will predict each and every outcome to be positive only, because it will be biased towards the yes outcome, and it will not have the ability to predict any outcome to be no or negative. Now, if that is the case, if our model is predicting all the 100% values to be yes, so here the true positive will be 92 and false positive will be 8. Those 8 values which were actually negative, but our model has predicted every value to be positive only. So here the true negative and false negative will be 0. So what is the accuracy then? Accuracy will be true positive plus true negative divided by the total predicted values. So true positive here is 92 and true negative here is 0. And the total predicted values are 92 true positive plus 8 false positive. That is 100. So our accuracy here is coming out to be 92%. Now look at this case. Our model is giving an accuracy of 92%. But is this model a correct one? Obviously not, because this model is not at all predicting any value to be no, because it doesn't have that ability. It is completely biased towards the positive outcome. Hence, if our model's accuracy is 90%, we can't say that our model is a correct one just by evaluating it with accuracy metric. Accuracy metric in this case is not performing well. So what other metrics are there to use in case of imbalanced datasets? We have other metrics like recall, precision, F beta score. Generally, F1 score is highly used. The ROC curve, AUC score, these are the metrics which can be used in case of imbalanced dataset. So this is it. Hopefully, I have covered the issue and I have solved the problem well enough. So if you like this video, kindly subscribe the channel for more such videos. I'm going to upload many such videos day by day. And please like the video, share this video as much as possible, and please subscribe the channel. Please be with me. Okay. Thank you. Thank you very much. And bye.